Good morning, students. I am back with Chapter 9, Force and Laws of Motion. In the 8th session today, let us do the 4 questions given in the pages 126 and 127 of your textbook. After that, we will start with the exercises and do the questions 1 to 6 in today's class. Now, let us start with the questions. Question 1 is, if action is always equal to the reaction, explain how a horse can pull a cart. Answer. First of all, the statement action is always equal to the reaction is nothing but Newton's third law of motion. In this case, where the horse is pulling a cart, two forces are acting. The first one is the force exerted by the horse on the cart, and the second one is the force exerted by the cart on the horse. You might wonder, how can the cart exert a force on the horse? This is simply the frictional force that arises when the wheels of the cart come in contact with the rough surface of the road. Also note that as long as the frictional force will be equal to the force exerted by the horse, the cart will not move. So the cart can be pulled only when the horse bends forward and exerts a force greater than the frictional force. Question 2. Explain why it is difficult for a fireman to hold a hosepipe which ejects large amounts of water at a high velocity. Answer. Here in this case, let us imagine a fireman holding a hosepipe and the water gushes out with high velocity. The forward-going water exerts a backward force on the hosepipe and pushes the pipe backwards. That is why the fireman finds it difficult to hold the hosepipe. From a rifle of mass 4 kg, a bullet of mass 50 grams is fired with an initial velocity of 35 meters per second. Calculate the initial recoil velocity of the rifle. Given here are the mass of the rifle 4 kg, mass of the bullet 50 grams, and the velocity of the bullet 35 meters per second. And we are supposed to find out the recoil velocity of the rifle. So first of all, we find out the momentum of bullet. That is given by the formula mass into velocity. And the mass of the bullet, 50 grams, is converted into kg by dividing by 1000. And so here we get the momentum after the calculation as 1.75 kg meter per second. Suppose the recoil velocity of the rifle is v meter per second. Here again we find the momentum of rifle, this time using the formula mass into velocity. The mass of the rifle is 4 kg and the velocity we have considered as v meter per second. So that comes to 4v kg meter per second. Now, according to the law of conservation of momentum, momentum of bullet equals momentum of rifle. So 1.75 from equation 1 equals 4v from equation 2. So v equal to 1.75 upon 4. Therefore, the velocity v equal to 0.4375 meter per second. Question 4. Two objects of masses 100 grams and 200 grams are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second respectively. They collide, and after the collision, the first object moves at a velocity of 1.67 meter per second. Determine the velocity of the second object. Here we have the masses of the two objects. One is 100 grams and the second object is 200 grams. Their initial velocities of the first object u1 is 2 meter per second and the second object u2 is 1 meter per second. After the collision, The new velocity v1 is 1.67 meter per second, and we are supposed to find out the velocity of the second object after collision. So here, first of all, we find out the momentum of the first object before collision using the formula mass into velocity. Here, the 100 grams is converted into kg by dividing by 1000. And so, the momentum we get of the first object is 0.2 kg meter per second. Next, we find out the momentum of second object before collision. Here again, we use mass into velocity, and the 200 grams is converted into kg by dividing by 1000. And the answer we get here is 0.2 kg meter per second. Total momentum is given by the momentum of both the objects before collision. So we have 0.2 plus 0.2, that equal to 0.4 kg meter per second. Now after collision, the velocity of the first object of mass 100 grams becomes 1.67 meter per second. So the momentum of the first object is given by the mass into this velocity, and that comes to 0.167 kg meter per second. After collision, suppose the velocity of second object of mass 200 grams becomes v meter per second. So this time the momentum of second object is the 200 by 1000 kg into v meters per second. This equals 0.2 v kg meter per second. And the total momentum after collision is given by 0.167 plus 0.2 v. Now from law of conservation of momentum, total momentum before collision equals the total momentum after collision. So we have 0.4 equal to 0.167 plus 0.2 v. 0.2 v equal to 0.4 minus 0.167. This implies v equal to 0.233 upon 0.2. Thus, the velocity of second object is 1.165 meters per second. Now, let us start with the exercises given on page 128 of the NCERT textbook. The first question is, an object experiences a net zero external unbalanced force. Is it possible for the object to be traveling with a non-zero velocity? If yes, state the conditions that must be placed on the magnitude and direction of the velocity. If no, provide a reason. Answer: yes, when an object experiences a net zero external unbalanced force, it is possible for the object to be traveling with a non-zero velocity. This can happen under the following 5 cases. They are: the object should already be traveling with a uniform speed in a straight line path. Second case is, there should be no change in the magnitude of speed. Third case is, there should be no change in the direction of motion. The fourth case is, the friction between the object and the ground must be zero. The fifth case is, the air resistance on the moving object must also be zero. Question 2. When a carpet is beaten with a stick, dust comes out of it. Explain. The answer is, when a hanging carpet is beaten with a stick, then the force of the stick makes the carpet move to and fro slightly, but the dust particles in it tend to remain at rest, or rather stationary, due to their inertia of rest, and hence come out of it. Question 3. Why is it advised to tie any luggage kept on the roof of a bus with a rope? The answer is, it is advised to tie any luggage kept on the roof of a bus with a rope because A. If the bus starts moving suddenly, then due to its inertia of rest, the luggage kept on the roof of the bus tends to remain at rest and hence may fall down from the roof of the bus. B. If the moving bus stops suddenly, Then, due to its inertia of motion, the luggage kept on the roof of the bus tends to remain in motion and hence may fall down from the roof of the bus. But if the luggage kept on the roof of a bus are tied with a rope, they cannot fall down when the bus starts suddenly or stops suddenly. Question 4. A batsman hits a cricket ball which then rolls on a level ground. After covering a short distance, the ball comes to rest. The ball slows to a stop because 4 multiple choice is given. A. The batsman did not hit the ball hard enough. Or B. The velocity is proportional to the force exerted on the ball. C. There is a force on the ball opposing the motion. And the last option D is there is no unbalanced force on the ball, so the ball would want to come to rest. The answer is C. There is a force on the ball opposing the motion. Question 5. A truck starts from rest and rolls down a hill with constant acceleration. It travels a distance of 400 meters in 20 seconds. Find its acceleration. Find the force acting on it if its mass is 7 metric tons. Here, a hint is given: 1 metric ton equal to 1000 kgs. In the first part, A, we are supposed to calculate acceleration here. Given here are initial velocity u equal to 0, the distance travelled by the truck s equal to 400 meter, the time taken t equal to 20 seconds, and we are supposed to find the acceleration A. Here we use the equation of motion s equal to ut plus half at square. Substituting the values of s as 400, u as 0, t as 20, and solving the equation, we find acceleration A equal to 2 meter per second square. Thus, the acceleration of the truck is 2 meters per second square. The next part is B, calculation of force. Force equal to mass into acceleration. But here, the mass given is 7 tons. But we are supposed to take mass in kg. So we convert it as 7 into 1000. So force equal to 7 into 1000 into 2. Therefore, the force equal to 14,000 newtons. This is the force acting on the truck. Question 6. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between the stone and the ice? Given here are the initial velocity u equal to 20 meters per second. The final velocity v of the stone is 0 because it comes to rest. And we are supposed to calculate the acceleration. And the distance travelled by the stone s equal to 50 meters. Here we use the equation of motion v square equal to u square plus 2as. Substituting the values of v as 0, u as 20 and s as 50, we get a equal to minus 4 meter per second square. Now force F equal to mass into acceleration. That equals mass is 1 kg and the acceleration is found to be minus 4. Therefore, substituting the values, F equal to minus 4 newtons. Thus, the force of friction between the stone and the ice is 4 newtons. The negative sign shows that this force opposes the motion of stone. That's all for today, students. Thank you.